Hello, this is Britt Caswell with another video on graphing quadratics. In today's video, we're going to be looking at factoring quadratics in factored form. So factored form is usually written out as either f of x or y is equal to a times x minus p times x minus q. So what's nice about factored form is this p and q value. These are our zeros of our function. Now, it's important to remember here when we say zeros, we're talking about these here, the x-intercepts, also called solutions. But these zeros often look like you're flipping signs when we go to deal with them. So just recognize the zero is whatever is being subtracted from x. When we go to do an example here in just a moment, you will see where it causes the signs to flip. Alright, so when we go to graph, we usually want 5 points. Okay, we get our usual suspects, is what I call those. So the zeros, again, you get them by setting the factors equal to 0 and then solving for them. Just writing that out. Okay, another really important one is to find this axis of symmetry, which is this vertical dotted line that you see here. So all parabolas happen to reflect over their axis of symmetry like this. And on the axis of symmetry, you have either your smallest value, called a minimum, or your largest value, called a maximum. And it happens here at the vertex. So our next usual suspect here is the axis of symmetry. And I usually say slash vertex, because in order to find the vertex, you have to find the axis of symmetry first. Okay. Now the axis of symmetry does have a nice little formula. It has a little rhyme to it. It's x equals p plus q all over 2. So to find your axis of symmetry, you find your zeros, plug them into this formula, and then to find the vertex, you plug that x value in to find y. Okay, so then our last usual suspect is usually the y-intercept. So the y-intercept is where the parabola crosses the y-axis. It's right here on this one. Now, with the y-intercept, the x value at that point is 0. So in order to find the y-intercept, you're going to plug a 0 into the function. Now, often with graphing, we want 5 points on our graph. If you notice, right now we only have 4. So because quadratics are symmetrical, it's really easy to find a 5th point by reflecting the y-intercept across the axis of symmetry. So I always reflect the y-intercept to get my 5th point. That also makes it nice to tell that there's a smooth curve going on there. So let's go ahead and let's do an example. Okay. So again, we start with our zeros. Okay, zeros are the value where it's crossing the x-axis. So in order to do that, I take the factors. So in this case, the x minus 2 and set it equal to 0. And I'm going to take the x plus 4 and set it equal to 0. And on these, we just now solve for x. So to get x alone here, to undo the subtracting of 2, I'm going to add 2. So I get that x is 2. And here to undo the plus 4, I subtract 4 from both sides and get x equals negative 4. So those are my 2 zeros. The next thing I look at is the axis of symmetry. Okay, now the axis of symmetry is a vertical line, which always has x equals. It's a little different than these zeros, in that these zeros should really be ordered pairs, but a lot of people tend to not bother writing them as ordered pairs. I find that that can be sometimes confusing for students. Now the axis of symmetry is a line, so it doesn't get an ordered pair treatment, it just gets x equals some kind of number. This also pairs with my vertex. So once I find what that axis of symmetry is, that x value, I can write it right there for the point for my vertex right away. So the little rhyme I told you, x equals p plus q all over 2. So I'm going to take my two values that I got, 2 and negative 4, and I plug them in. So here at the top, 2 plus negative 4 is negative 2, and negative 2 divided by 2 is negative 1. So the axis of symmetry for this parabola will be at x equals negative 1. Now the vertex lies on that axis of symmetry, so I could put the negative 1 in for that. And in order to find the y value for my vertex, I just plug that negative 1 into the function. So I get y equals 3 times negative 1 minus 2 times negative 1 plus 4. So if I simplify my parentheses first, negative 1 minus 2 is negative 3. Negative 1 plus 4 is a positive 3. And 3 times negative 3 times 3 is negative 27. So this graph will be way down at negative 27. The next thing I look for is the y-intercept. So remember, the y-intercept is a point as well, and the x value for that point is a 0. I also will be doing my reflection once I find my y-intercept. So the y-intercept and its reflection, they have the same y value because they're at the same height, but the x values are different. So what I tend to do is I tend to look at the difference from the vertex to the y-intercept. So that's a difference of negative 1. And then I double that. So my reflection will be at negative 2. So now we just have to find that y value. So to find the y value for the y-intercept, if I could spell it, I'm going to take the function, and where the x is, I'm going to plug in a 0. Now some people say just to multiply together all of the end numbers, which you can do as well. It's just a little shortcut to actually doing this part here. So 0 minus 2 is negative 2, and 0 plus 4 is 4. So I get that y equals 3 times negative 2 times 4. That is negative 24. And that's what I'm going to plug in here for my y-intercept and for my reflection. Alrighty, so now we have our list of usual suspects, so we can go ahead and we can draw our graph. Now a lot of times you want to have like regular tick marks. For this, because my numbers are so large, I'm going to count by 3s. So that's what I'm writing up here. I'm going to say that I'm scaling by 3s. So every mark that I have is counting for 3. There's 3, 6, 9, 12, for example. Okay, and that graph's going to go way down that way. Alrighty, so I start with my zeros. I have my first 0 at 2, so that's 2 comma 0. My second one is at negative 4. My axis of symmetry is at negative 1. Okay, so I'm going to make my vertical line here and label that x equals negative 1. Oh, my pen didn't read that I picked it up. There we go. Now the vertex itself is way, way, way down. Okay, it's down at negative 27, which is right here. Notice whenever I draw a point on my graph, I am making sure to label that point with its coordinate pair. That makes it easier for anybody who has to look at your graph to quickly get the information that they need. My y-intercept is at 0, -24. And then my reflection is at -2, -24. And then with all 5 of those graphed, you can just draw your swoop through there. Hopefully a little better than I can on my little writing tablet. And there it is. Thanks for watching.